In this section, we're going to be comparing interest gained in different investments. Now, we saw a little bit of this in the last section. We saw that if interest is compounded on a yearly basis, then we can use this formula to calculate the final amount you have in the account. We saw that also if interest is compounded on a monthly basis, you can find the final amount given this formula. So what we're going to do in this section is look at our general formula for compounding interest and then do some comparisons. So the first thing we want to do is check out our interest formula. This interest formula is used when you compound m times per year. You can see the m located in our formula right here and also right here. The other variables stand for other amounts. So let's take a look at each individual variable separately. This P here officially stands for present value. It's the amount of money you initially put into an account or an investment. Now, the A is the amount of money you are going to have in that account or that investment at the end of the time. So a present value is a starting value, and that A is basically the end value. R stands for rate. That is your interest rate written as a decimal. We've dealt with that before. And T stands for time, specifically the amount of years you are going to let this account or this investment sit and gain interest. Let's think of this in terms of a running analogy. P is the starting amount, so that's basically where we start at. A is the final amount, that's where we're going to end at. T is time, obviously that's how long it takes to run. The R is rate, that's sort of like our speed. And the M, that's the number of times interest is compounded each year. So in one sense, you can think of that as the number of steps it takes in each little bit. So in each 10 yards, how many steps does this runner take? And so all of those are going to affect how interest is accumulated. And we're going to do some examples right now. So we're going to look and compare of how our final amount differs when we begin with different starting amounts. So we're going to begin with $2,000 and we're going to invest that. Our investment is going to be at 6% compounded yearly for 15 years. And then we're going to begin with $4,000 at 6%. Notice that this percentage is the exact same as here. We're going to also compound yearly. And we're going to also leave our investment to gain interest for 15 years. If we look at each one of these separately, you can see the present value, the rate, the M, and the T clearly show up. In our first example, the present value is 2,000. That's our starting amount. The rate is 6%. We'll translate that into a decimal of 0.06 when we put it into the formula. Since this is compounded yearly, that means that M is 1 for one compounding period per year. And we're going to leave the investment in for 15 years. So T is going to be 15. So when we put that in the formula, we're going to end up with A equals 2,000, parentheses 1 plus 0.06 divided by 1 in the parentheses to the exponent 1 times 15. The value that we get out is $4,793.12 when I round it to the nearest cent. That is the final amount. If you want to figure out how much interest was gained on your investment of $2,000, then you can simply take the final amount and subtract the present value of $2,000. And you can do that in your head or via calculator. I did it with via calculator. And I ended up with interest gained was $2,793.12. Again, that is the difference between the final amount and the present value. We may also do this with a doubled principal. So we're going to do this when I begin with $4,000 at 6% interest compounded yearly for 15 years. We would apply the same formula, only this time our present value is going to change from 2,000 to 4,000. When you plug this into your calculator, you will get out an answer. That answer will be $9,586.23. Again, that's the final amount you have if you invest $4,000 at 6% interest compounded yearly for 15 years. And in terms of interest accumulated, we can take our final amount and subtract our present value. Interest is how much money I've gained, remember? So final amount minus present value, that comes out to $5,586.23. Now, this is what I'd like you to notice. Notice that when you invest $2,000 versus when you invest $4,000 with the same interest, the same time period, and the same accumulations, when you invest $2,000, you end up with exactly half than when you invest $4,000. And your interest gained is also exactly half when you invest $2,000 versus when you invest $4,000. So the takeaway should be that this formula, when we change the amount of P, if we double the amount of P and leave all of these other amounts the same, A is also going to double. And that should make sense based on simple mathematics as well, because doubling P is just going to multiply this number, and order of operations says I need to do my exponents in my parentheses first, my parentheses, then exponents, then multiply. So I would calculate this number before I multiplied by P. And so doubling the principal, doubling that present value, ends up doubling the final amount we get, and also doubles the interest that is accumulated. In the following exercises, you're going to see how doubling R affects things, how doubling M could affect things, and how doubling T could affect things in this formula. So you'll be asked to do the other examples from this section on your own.